Alright, hi everyone. Let's continue with our data structures and algorithm series. Previously, we looked at how to calculate time complexity of our code with the help of bigger notations. We also saw some examples like O of 1, O of n, O of log n, and O of n square, which helped us in finding out the performance of our code with respect to the data, right? But if we are talking about performance, then time complexity is not the only aspect. There is another aspect of performance, that is space complexity, meaning how much memory is required in order to run our code, right? The resources are limited, so we have to make sure that our code or our algorithm takes less space in our system. We can calculate space complexity using big O notations, same as time complexity, right? And before moving on to the section where we will see how to calculate the space complexity, I would like to mention auxiliary space complexity. Auxiliary space complexity is the space required by the algorithm, not including space taken by the input. By this, I mean, for example, let's say we are having an input data as array. That array will require some space in the memory, right? But we are not going to talk about that input size. We are going to talk about the algorithm only. Now let's look at the space complexity of some of our data types. The primitives one like boolean, undefined, null and numbers have space complexity of O of 1. They require constant space. Strings require O of n space, where n is the length of string. Similarly, with arrays, arrays also require O of n space, where n is the length of array. And objects require also O of n space, where n is the number of keys. Alright, now let's take a look at an example and try to find out its space complexity using big O notation. In this example, we are trying to calculate the sum of all the numbers present in an array. We are trying to take array as an input and we are running a loop over all the elements of that array and trying to add them one by one into our variable called sum. After iterating over every element of that array, we are returning the final sum. Now let's try to calculate the space complexity of this program. Here in the first line you can see we are trying to assign 0 to our variable sum. As we mentioned previously, numbers have space complexity of O of 1. They have constant space complexity. So here till now the space complexity is O of 1. In the next line, we are iterating over all the elements of the array. Here, we are also assigning a number to the variable called I, right? So here also, the space complexity will be O of 1. Now remember, we are calculating space complexity and not time complexity. So we can ignore these operations where we are comparing and doing some addition and assignment. Now moving on to the next line, we are adding all of the elements into our variable. But remember, these are still numbers. So the space complexity will remain O of 1 here as well. In the end, we are simply just returning the sum. So the overall space complexity of this algorithm, remember we are not including the input data size because we are calculating auxiliary space complexity, which does not involve input data size. It only includes the algorithm space, and the algorithm space here is O of 1. Alright, that's all for this video. In the upcoming video, we will try to calculate space complexity of some complex examples. Thanks for watching.